Hello, in this lecture presented by www.free-academy.com, we're going to be doing problem 40 out of the textbook in combining functions. Now problem 40 gives us that we have two functions, f of x equals 2 minus x squared and g of x equals x to the third. And we need to find f of g of x and g of f of x. Now the analogy I like to use, if we were to find f of 4, we would simply put 4 for wherever we had x in the equation here. So, f of x equals 2 minus x squared, f of 4 equals 2 minus 4 squared. Or if we were to find f of a, we'd find 2 minus a squared. And if we were to find f of g, it would be 2 minus g squared. So if we were to find f of g of x, it would be 2 minus g of x squared. And in the problem we were given that g of x is equal to x to the third. So we'll replace that in our equation here to get 2 minus x to the third squared. Now the exponents multiply, so you end up getting 2 minus x to the 6 squared. It's absolutely no different whether you're using numbers, constants, or equations. You can plug them into your formulas just as easily as anything else. So now that we've done that with f of g of x, we can very easily go back and do this for g of f of x. And the other way I like to use to explain this is you just simply use x as a placeholder. So when you write out your g equation, you have x to the third, so you do parentheses raised to the third power. And then when you evaluate at f of x, you simply put the value for f of x into the parentheses there. And g of f of x gives us 2 minus x all raised to the third power. Now you can distribute that out doing the algebra if you like. It's not strictly necessary for solving this problem, so I'm going to omit those steps. But this is the general practice you do. You take your value for g of x and you plug it into f of x when you're finding f of g of x, and vice versa when you're going the other way around. And you can even do this with f of x, g of x, and h of x, and as many functions as you like. In fact, we'll get to those problems where you have 3 and more that you're combining.